I'm CK. Tonight we've got another one from Gikfun. This is a remote controlled nightlight and looks like it's got a number of little things inside. Doesn't look like there's any surface mount. Looks like it's a good through-hole practice kit. We'll put it together, see what we can learn from it, and see how much fun it is. And I hope you enjoy the video. It's the box. It's a nice little plastic box. It'll be reusable for other things when I get done with this. Let me get some of these resistor leads off from my last kit. And where did I put my garbage can? Golly. Okay, now we're set up for success. Made in China, Gikfun remote control, something student EK1329. That EduKit 1329. Got some tape to hold it shut. Okay, try and get that off, and I did. And I wrapped it around my pointy thing, which is what I did not want to do. Oh, come on. There we go. Let's open up the little box. Got a piece of paper. Let's take a look at it. Remote control nightlight kit instructions. And yeah, it's from EQ-Kit. And my hat just fell off. And tools you need: 30-watt soldering iron, solder wire, a multimeter, tweezers, wire cutters. Always measure resistor values before soldering. And step by step, the resistors on one line, the capacitors, LED, triode, or as we say, transistor. Voltage regulator, that's interesting. They often don't have a voltage regulator. That's the board says it's a 78 LO5, so that's a 5-volt voltage regulator. Switch, infrared receiver for the remote, and the IC, which is a CD4017, which I think is just a counter divider, but I'll look that up just to be sure. Switch on the back, DC socket, or battery wire, so you can plug it in or use the battery. Put it in the box. Maybe we reuse the same box, I guess. And then here we have the schematic, which is very nice. So it takes 9 volts in, and here's the 78 LO5 to reduce that to 5 volts. So you can get DC or battery, either way works. And then we've got voltage in, ground, and out going to this transistor. I guess that's the, I think that's probably the IR receiver. Let me see, 1738. IR receiver, 1738, yeah. So when the IR receiver gets something, it toggles the transistor, which, yeah, this is a, this 4017 is a counter. So every time you hit the IR signal, it'll bump this transistor and send signals in to the counter to count things up, and I'm going to assume that's going to change the intensity of these LEDs. Here's the current limiting resistors for these LEDs: 2 in series, 4 in parallel, and 1, 2, 3, 4 groups of them, even though this one's got 6 LEDs. Okay, pretty straightforward circuit. So that's what we've got. Let's look at the actual bits and pieces. This circuit board, which is a good one. I mean, it's through-hole plated. They've really, EQ-Kit has really upped their game in the circuit boards. They're not the less expensive green single layer boards anymore. These are actual dual layer boards. And diodes, resistors, switches, 7813 transistor, and a, no, that's, what is that? That's the, no, that's the IR receiver, the 7838. The voltage regulator goes here, transistor goes here, transistor 1 goes here. Where is transistor 2? Oh, over here. Then we've got the bag of stuff. Let's get a parts tray over. out. Oh, it doesn't actually come with an IR remote. I've got a bunch of them, so maybe they've got one of them will perk up. Here's 4 screws, because again, I think we can't reuse this kit. I think they want to use this box as the holder for this? I'm not quite sure how that's going to work. But we'll, oh, I see, because we've got some spacers to put on it. We've got these nylon spacers that we'll put on there so it'll stand all up. Got a bunch of LEDs, some electrolytic caps, some disc caps, 104 decoupling caps. Here's the 4017, and it's got an outline of Texas, kinda, but it's actually a phony TI chip. It's a knockoff TI chip, which is not unusual. Now let's take a look at these LEDs. I'll get my LED buddy out. Built this, geez, maybe going on 2 years ago now, and it's really handy. I've got a video on the channel. So let's check this LED out. Oh, nice and bright white, 3.2 volts, that's high voltage. And 120 ohm inrush resistor for that. Let's see if I reverse the polarity, if it's a dual color one, and it is not. Let me grab a couple of them, make sure they're all the same color. Yep. Yep, they're all white. So that's it. Looks like pretty straightforward to put together. Oh, here's the infrared receiver chip. The little bulge side is where the actual infrared signal gets read in from. So let me get the soldering iron heated up and we'll put this thing together. As usual, we are going to start with resistors, and we're going to start with the 330 ohm, 330R, in other words 330. And let's do one of them first. We'll do R5 first. So we'll learn 2 things. We'll learn how the how the circuit board takes solder, and we will also see how close we have to bend the resistor leads to the body to fit. And it looks like just snug. Nothing, no extra space and no pinching very tightly. Now we'll solder at the legs, see how it goes. Oh yeah. Board takes solder very well. So I've got the resistors here. There aren't many of them tonight, but we have talked about everything that's interesting about resistors. So I will go ahead and put the rest of them on with no commentary, and I'll speed up the video playback. So enjoy resistor time. That was quick resistor time for this kit. And now we'll do the 2 104 decoupling caps, disc caps, that'll probably go right by the IC, and they do. There's one, and where's the other one? Oh, it's all the way over here. Huh, interesting. I'm not going to solder them right now. I'll wait for a couple more things to go on. And now we have the electrolytic capacitor, which is, we've got 2 of them. And they should be 10 microfarad. That's one 10 microfarad. And that's, the other one's 10 microfarad. And as you can see on the board, where's my pointy thing? As you can see on the board, I hope, there's a good plus sign and a shaded area, so you know where to put the long lead and you know where the stripe side goes. So you're not going to put them in backwards, because if you put them in backwards, interesting things will happen. It might even work in a halfway sense, but it won't be good. And he would like us to do all the LEDs at this point. Well, I probably will do that, but let me get these things soldered first because I want these leads out of the way before I start doing the LEDs. Now we'll approach the LEDs, and they also have an okay indication. It's not the best. There is a line tangent to the circle that shows you where the flat side or the negative side goes, and the square pin or the square hole is for the long pin. So I'll put all of these on first, then we'll talk about how we're going to approach soldering them down. And there's all the LEDs positioned. They gave us 2 extras in case any of these are bad. I could have tested them all with the LED Buddy, but I didn't want to because I'm lazy. And over the last few years, LEDs have become so reliable, I'm not really worried about it. So what we're going to do, I want to make sure they're all really flat on the board. So what I do is I will solder one lead, and then I will put my index finger on the LED on the other side of the board, press firmly, reheat that solder. You might have seen it jump a little bit. It's now flat on the board. And of course, the next thing to do is wait for the solder to cool so it doesn't move. Take your finger away, and then it's completely flat. So I'm going to do that for all the LEDs. I'm going to do one leg, press it down firmly, then do the other leg. Actually, I'm going to do all the one legs first, and then go back and do the second legs, just because that's more efficient for me. And I will speed this up and very likely cut some of it out. All the LEDs are flat to the board and soldered completely. Now we'll put the transistors on, and we got to make sure we get the transistors and not the voltage regulator. This is the voltage regulator, the LO5. We want the 8550s, and there are 2 of them, I think. They're both the same. They are both the same. Just make sure you have the flat side of the transistor facing the flat side printed on the circuit board, or else things will just not work at all. And I'm going to put the voltage regulator on. Same thing, flat side to the flat side of the printing on the circuit board. And I want to take another look at this schematic for a second. Okay. I'm gonna, should I solder these down? I think I'll do the switch and the infrared receiver chip also while I'm got this grouping of stuff going in. Same thing with the infrared receiver. It's got a flat side and it's got a bulge. Both of them are shown on the printing on the circuit board. And I'm trying to spread the legs out so it doesn't fall out, but they've decided to become as one, being annoying. Don't be annoying, little guys. So that's one. Oh, okay, there are 2 switches. There's a regular momentary switch, and then there's a 6-pin switch. The 6-pin is the on-off switch, and the toggle is down here. I guess, oh, I see. So the toggle can be used, this switch can be used to adjust the brightness, which I'm assuming is what the infrared remote does based on this circuit here. Oh, you can't see what I'm pointing at. Sorry. So the switch is over here for the power, and that's this one, the 6-pin. And then this momentary switch is here. So where'd my pointy thing go? Golly, there it is. So as you can see, when you've got VCC and ground going into the infrared receiver, this is your positive voltage, this is ground, and when the receiver receives a signal, it sends it out. So here's the ground voltage, here's the inside voltage, and you have the other option. You can close this switch and that will make the same path as the infrared receiver chip. So where was I? Don't confuse yourself. And we could do the IC right now, but we won't. I'll solder these things down and clip off the leads. And I talked about the switch, but I didn't actually put it on. So I will do that also. Let me set this down for a second. Now, you'll notice there's a little square box inside the diagram. On the bottom of the switch, there's a little box right here, and that's what they're saying needs to be matched up. So I'll put that in there, and it goes in there very loosely. So I'm going to get a little piece of foam and rest it on that foam while I solder one leg of it. And I'll be doing basically the same thing that I did with the LEDs. So I've got one leg soldered, and I'm double checking to make sure it's all flat. It is, but I'll go ahead and do the same thing, just heat that solder ball up again, just to make sure everything is flat. Now I'll do that switch and the other switch. I'll solder that switch and the other switch. Now be a little bit careful here, because these solder pads are very close together, and you don't want to bleed from one to the other, or your life will be confusing, because you'll say, well, it's supposed to work this way, and it doesn't. Now we'll put the counter chip in, and as you can see, we're not going to be using a socket. We're just going to be installing the chip directly on the board, and which makes sense, because realistically, if this chip ever fails, which is unlikely to begin with, if it ever fails, you're going to toss this away. You're not going to find a replacement chip. Now, there's a notch printed on the board, and there's a notch on the chip, and they of course have to be on the same ends. They have to match. And there it goes. That went in pretty well, and it's pretty snug. I'm not going to have to support that while I solder it. And that went on quickly enough. I'm double checking the notch. Hopefully it's right, because ICs, when you directly solder them like that, are a bit of a pain to take back out if you rework it. If you need to rework it, we'll put the DC power supply on, and we want to put it on the back, not on the front. And it's center positive, DC 9-volt center positive. Let me get my little piece of foam back. Set that down like so. Grab another piece of solder, a thicker piece of solder. You don't have to. I just happen to have a thicker piece of solder lying around on the workbench. Make sure you don't put your soldering tip against the LEDs you've already installed, of course. Practice vertical soldering. There. That's in there well. I'll get the other two positions. Now, I often use external power supply, but today I've already got a 9-volt rechargeable battery hanging around on my workbench from a project I did the other day, so may as well use that. And we're going to put the red wire through the square hole, the one marked with a plus sign for the positive side of the battery. Give it a little tug. Yep, it's in there tightly. Solder has bled through the through-hole plated holes. Now we'll put the black wire, the negative wire, through. I could trim those, but I'm not gonna. And now what we're going to do is we're going to take our spacers, and I think what we're going to do is we're going to take these little black screws that we didn't take out of the bag before because we didn't want to have them rolling around all the time. I think we'll put them through one, like so, then put that through one of the holes, then take this little guy and screw it on. Oops! And have it almost fall on the ground, but it didn't. And screw that onto it. I'm not going to try and tighten that very much because it doesn't make much difference. There's not going to be a lot of stress on it. It's just making some support legs. Screw goes through. Screw goes through the hole. Short little guy gets screwed on like that. Oh, and you may notice this hole would allow you to thread the battery wires up and then down into those pads. I didn't see any reason to do that. That's just a little more complexity than I cared to deal with. But right now, we've got it all assembled, except for putting it in the box. I think what they want us to do is just put it in this box and then close it up, and you've got your little night light. Of course, you got to peel the sticker off. Now, before I put the battery on, I'm going to go over and get one of my infrared remotes. Actually, here's one. I have no idea if this is going to work. I don't even know if this has a battery in it. Let me double check. Well, I've got two infrared remotes just in case, so I'm going to lower the light a little bit here, even though, again, modern cameras are so good they compensate for that very well. I'm going to make sure the switch is positioned out. And I'm going to connect the battery, and out is the wrong way. Nope. Okay, the battery's there, kind of tucked under. Now I'll turn that on. That's using the manual. Oh, I guess that switch turns on different intensities. Okay, so with this out, the inner ring goes on. With it in, the inner ring is off. And then this switch just turns it on and off. Let's see if we can get that to happen with this IR remote. Oh yeah. It's not staying. I bet this is pulsing. Some IR signals, the infrared diode will pulse rapidly to make sure the signal's getting across, and maybe that's what this is doing. Or I wasn't just doing it right. Now we'll set the inner on, because you can't control that one with the remote except in the broad sense. But I don't think you can. Oh, look at that. I'm pressing any button. It's very non-discriminatory. It says any infrared signal. Try the other remote. Yeah, I didn't think that had batteries in it. Any infrared pulse signal in that rough frequency band, I'm going to turn on and off. Okay, well, you could be that way. So let's put it, now that we see it works, which is always a good thing, now we'll tuck it into its little box. Block it all up. And there's your little infrared nightlight. And, oop, stay closed, little buddy. Are you all the way down? You are all the way down. And there you go. Turn your little night light off and on from wherever you are in the room. So that was a fun little kit. Good schematic showing you what's actually happening. Let me turn this off so the cameras will recover. Good schematic. Clear as a bell instructions, so that's really nice. And a useful little device in the end. So another good one from EQ Kit and Gikfun. I hope you enjoyed the video.